Alright, hello once again. So now we are working on proofs using the isosceles triangle theorem. It is a little bit difficult to create a whole bunch of different proofs that have to do with the isosceles triangle theorem. So they don't vary too much. They're a little bit longer because now you have a lot of information that you can work with. They go back to the beginning of the school year when we did the different properties and angle addition, postulate, and all that stuff. So you're going to be pulling in all the information that you've learned throughout the school year. This first proof, we've been given that side xy is equal to side xz, and we've also been given that oy is equal to oz. And what we want to prove is that angle 1 is equal to angle 4. It might be a little bit difficult to see. Those are up at the top here. Let me change colors so I can kind of highlight it. Here's 1 and 4. That's what we're trying to prove, that those two are equal. So our first step is going to be to start with our givens. In this specific case, I would start with just one given instead of both of them. I'd pull the second given in later. Even though they're very similar, it would just, it makes more sense, it flows easier in the proof to use just one at a time. So our first step, we're going to use just the first given. Xy is equal to xz. Now if xy is equal to xz, that makes the large triangle an isosceles triangle. So based on that information, if I use the isosceles triangle theorem, I know this entire angle, xyz, has to be equal to this entire angle, xzy. So that's going to be my second step to say that angle xyz is equal to angle xzy by the isosceles triangle theorem. The next thing is, I know that I need to get it to that numeric form. I want to use the numeral names of those angles and not the letter names. So what I need to do is create that transfer. I want to say that angle xyz is equal to angle 1 plus angle 2, and angle xzy is equal to angle 3 plus angle 4. And I'm allowed to do that because of the angle addition postulate. Remember, we learned about that before. If you add two angles to create a single angle, that's the angle addition postulate. Well, since angle xyz is equal to angle xzy in that top, well, in part number 2, I can take angle 1 and angle 2, substitute that in for xyz, and I can take angle 3 and angle 4 and substitute that in for xzy. So now that gives me that angle 1 plus angle 2 equals angle 3 plus angle 4. And all I did was replace one thing with what it was equal to, so that's substitution property. Now I've gotten into that numeric form of the angles, but I need to narrow it down. I need to get rid of the 2 and the 3, so that way I'm left with just the 1 and the 4. This is where our other given comes into play. So now we're going to add that in. So we have OY is equal to OZ, given. And if OY is equal to OZ, then the angles opposite of those sides have to be equal also. So we're looking at the smaller triangle. We're looking at triangle OYZ. Opposite of OY is angle 3, and opposite of OZ is angle 2. So angle 3 has to be equal to angle 2 because of the isosceles triangle theorem. So now we know that angle 1 plus angle 2 is equal to angle 3 plus angle 4, and angle 3 and angle 2 are equal. So I can take angle 3 away from one side and angle 2 away from the other side, and again it'll stay a balanced equation. So if I take 2 away from the left, I have angle 1, and if I take angle 3 away from the right side, I have angle 4. We take it away by subtraction. And that's what we are trying to prove, so we are done.